There's a structure that can cool an entire home by up to 17 degrees in the dead of summer. No air conditioner, no compressor, no moving parts, and not a single watt of electricity. It sounds like a scam. But 3,000 years ago, entire cities ran on this. Kings cooled their palaces with it. Doctors used it to keep patients alive through deadly outbreaks. And then, almost overnight, the modern world walked away from it and started paying for the exact same comfort every single month for the rest of our lives. So if it works this well, why did the building industry quietly bury it? Stick around, because the answer is stranger than you'd expect. To understand where this begins, you have to leave the modern world completely and travel to one of the most brutal places humans ever decided to call home. Central Iran. Roughly 3,000 years ago, a city called Yazd, sitting on a high desert plateau where summer temperatures regularly blow past 113 degrees Fahrenheit. Now think about that for a second. No electricity, no refrigerants, no way to escape the heat. By every logic we use today, that city should have been unlivable. But it wasn't. It thrived. Because the architects of Yazd understood something we've almost completely forgotten. That you don't need to fight the heat. You can engineer a building to move it. Their solution rose right out of the rooftops. Tall, elegant towers called badgirs, wind catchers. From a distance they looked decorative, almost like chimneys reaching for the sky. But they weren't decoration. They were machines. The world's first solar-powered engines, built entirely out of stone. Here's the genius part. The thick masonry stayed cool in the shade, while the top of the tower baked in the sun. That difference in temperature created an invisible pull, a constant silent current of air flowing through the building, day and night, powered by nothing but the sky. And they didn't stop there. In many homes, these towers were connected to underground water channels called qanats. The incoming air was dragged across cool water before it ever reached a room, chilled by evaporation, like a desert breeze rolling off a river. A natural air conditioner, centuries before electricity existed. For hundreds of years, this was high-performance cooling, the global standard. Then, something unexpected happened. As the British Empire pushed into India and Africa in the 19th century, their engineers stumbled onto these strange towers and started bolting them onto colonial hospitals and barracks. Inside those wards, something strange showed up in the records. During cholera and influenza outbreaks, the kind that emptied entire buildings, the wards with these towers had noticeably lower death rates. At first, doctors assumed it was luck, or better medicine. It was neither. It was physics. The towers were constantly flushing the building with fresh outside air, sweeping out the stale, moisture-heavy air where pathogens love to linger. No medicine, no machinery. Just a building that knew how to breathe. And that single idea, a building that breathes on its own, is the entire secret. So let's break down exactly how it works. Forget everything you picture when you hear the word chimney. This isn't about smoke going up. It's about using the sun as a silent, invisible pump. Here's the whole thing in one sentence. Hot air is lighter than cool air, and a solar chimney weaponizes that. Picture a tall, narrow shaft on the sunny side of a house. The outer face is dark, usually black metal or stone, sealed behind a pane of glass. Sunlight passes through the glass, hits that dark surface, and turns into heat, trapped, exactly like the inside of a car on a summer day. Now the air inside that shaft gets hot, and here's the key. When air heats up, it expands and gets lighter, lighter than the cooler air around it. So it does the only thing it can do. It rises, fast, straight up and out the top of the chimney. But air can't just vanish without something taking its place. As all that hot air rushes out the top, it leaves a kind of vacuum at the bottom. And nature can't stand a vacuum. So the house inhales. It pulls fresh air in from the coolest, most shaded part of the building. A low north-facing vent, or even a pipe buried in the cool earth. That cool air gets dragged through your living space, soaks up the heat from inside, and then it too rises up the chimney and out. A continuous, silent river of air. No fan, no motor, no bill. Now here's the part that should genuinely impress you. A normal air conditioner gets weaker on the hottest days. It strains, it struggles, it draws maximum power right when you need it most. The solar chimney does the exact opposite. The hotter the day, the more sunlight hits that dark plate. The hotter the shaft gets, the faster the air rises, the harder the whole system pumps. On a blistering 100-degree afternoon, the moment your AC is gasping, this thing is at full throttle. It's a cooling system that gets stronger precisely when you need it most, which raises an obvious question. If the physics are this clean, is there any actual proof it performs in the real world? There is, and the numbers are hard to argue with. In 1995, researchers at the University of Arizona ran a long audit on a real solar chimney built into a home in the Sonoran Desert, one of the hottest, driest environments in North America. The results were almost hard to believe. While the desert air outside climbed to a punishing 106 degrees Fahrenheit, the inside of that home sat at a comfortable 75. More than 30 degrees of cooling, pulled out of thin air, using nothing but sunlight and the weight of the atmosphere. But temperature was only half the story. The real magic was in the air itself. Here's a number most people have never heard. The EPA estimates that the air inside your home is often 2 to 5 times more polluted than the air outside. That's because a modern sealed-up house with central HVAC mostly just recirculates the same stale air, typically less than half an air change per hour. Trapped chemicals, trapped moisture, trapped CO2. A solar chimney does something completely different. It delivers between 8 and 12 full air changes per hour of fresh, filtered outdoor air. That's like leaving every window in your house open, all day, every day, without the security risk or the heat. It's the reason those old hospital wards stayed healthy. And then there's the cost. To your wallet and the planet. Building, running, and eventually replacing a standard 3-ton central AC unit over 15 years carries a carbon debt of roughly 25 tons of CO2. A solar chimney made of masonry, glass, and recycled aluminum? Its carbon payback is under 6 months. After that, the running cost is exactly zero. Forever. The biggest study of all came out of the University of Nottingham, which found that buildings using solar chimneys could cut their total cooling energy by up to 75%. So let's be honest about what we're looking at. The physics is sound. The data is solid. The history is 3,000 years deep, which makes the real question impossible to avoid. If it's this good, why is it almost illegal to build one in America? Here's where the dream meets reality. And where I have to be straight with you, because this technology is not a magic bullet. Let's start with the uncomfortable truth the conspiracy crowd gets half right. The modern building industry runs on one thing: speed and standardization. It is dramatically cheaper and faster for a developer to throw up a thin-walled box and then pay an HVAC contractor a few $1,000s to bolt on a machine. It's plug and play. It requires no special architectural knowledge, no careful design, no thinking about where the sun sits. A solar chimney is the opposite. It has to be designed into the building from the start. Get the height wrong, the orientation wrong, or the venting wrong, and you don't get cooling. You get an expensive decorative shaft that does nothing. Then there's the regulation trap. And this is the part that actually borders on absurd. In the United States, building is governed by the International Residential Code, and that code is written almost entirely around mechanical systems, compressors, ductwork, fans. A solar chimney doesn't fit the form. Its output changes with the weather, so it can't earn a fixed efficiency rating. It has no UL listing, no Energy Star sticker. In the eyes of the code, it isn't a product at all. It's an architectural feature, and the rulebook barely knows what to do with it. So in practice, most inspectors will demand you install a conventional mechanical backup anyway, which means you pay for the chimney and the machine you were trying to avoid. It's not a ban on paper. It's a ban through paperwork. And yes, there's an incentive problem too. Utility companies and equipment makers earn nothing from a system that never breaks, never needs a filter, and never sends a monthly bill. Nobody's funding ad campaigns for a hole in your wall. But here's where I have to push back on the hype, because the chimney has real limits that have nothing to do with any conspiracy. The biggest one is climate. A solar chimney is brilliant in hot, dry, sunny places. The American Southwest, southern Spain, Australia. But in humid regions like the US Southeast or much of coastal Europe, it runs into a wall. It moves air beautifully, but it does not remove humidity. On a muggy 90-degree day in Florida, pulling in more outdoor air just means pulling in more wet air. You'd feel ventilated, but not comfortable. It also depends on the sun and the design. On a still overcast stretch, the pump weakens. And without that buried earth tube, it can't cool air below whatever temperature is already outside. This is engineering, not magic. And it only works when the climate and the design actually cooperate. So, should you build one? If you live somewhere hot and dry, and especially if you're designing a new home or chasing energy independence, this is one of the smartest, most durable investments you can make. A well-designed solar chimney can slash your cooling costs, scrub your indoor air, and keep working through a blackout, a fuel shortage, or a grid failure. For off-grid and self-sufficient living, it's close to unbeatable. But if you're in a humid climate, or you rent, or you simply want something you can buy off a shelf and forget about, this probably isn't your answer, at least not on its own. And maybe that's the real lesson here. This technology was never truly hidden by some shadowy villain. It was just quietly set aside, because it couldn't be boxed, branded, and billed to you every month. Which makes you wonder how many other brilliant forgotten ideas got buried for the exact same reason. One of them is the Trombe wall, a design that can cut your heating bill by up to 70% using nothing but a pane of glass and the sun. We break it down next. And if rediscovering this kind of lost engineering is your thing, subscribe, because almost none of it disappeared for being broken.